Hi friends, this is V. Naveen, Assistant Professor from Department of CST from METS Madanpalli. Today we are going to discuss about some of the basic introduction concepts on software engineering. That you all are aware that in recent days the development of more software is much emerged in IT sector to get solutions to the many real world problems. Yes, I am right. So that ultimate goal of evaluation of new software may lead to more errors and bugs. So important area that is going to be need to be focused is about testing. So especially in IT sector, this testing makes major role nowadays. It's equal to the programmer who is programming the software, and it's definitely it need to be tested before it delivered to the customer to ensure the ultimate solution that what customer expects is being produced in that software. So that the major objective of studying the software testing is to test the software before delivering to a customer. It's going to be a defect-free one. Okay. So in our curriculum, we have a software testing subject with the code of 18 CSE 306. Today we'll discuss some of the basic introduction part in the software engineering. So before entering into the subject, just we'll discuss some of the objectives of this course. So the objectives of this course is to study the basic software debugging methods, to enable the students to understand the various testing methodologies, and to study the procedure for designing the test cases, and to enable the students about the significance of software testing. So the basic objective of this to software testing is to we are going to read many more methods about software debugging, and we are going to ensure various testing methodologies which is being used in software testing, and we are going to study the procedure for designing the test cases to test the software, and we are going to enable the students to know about the significance of the software testing. Okay, so next we'll discuss about the course outcome. So at the completion of this course, definitely student will able to understand the basic principles of testing like path testing, and we are going to compare the different path testing strategies. So, and we are going to have an different transaction flow and data flow testing techniques is going to be understood by the student, and student can able to identify the various domain testing strategies, methods, and defining the methods to find out regular expressions used to find the testing paths. And we are going to test, and student can able to test the functions and state of the applications manually and by automation by using the different testing methods. And student can apply use of this testing software testing methods by various testing tools. So these are all the outcomes of the students after the software testing courses is going to be completed. Okay, so next we'll move on to the unit 1. So unit 1 we are going to discuss about the basic principles of software testing, part testing, basic principles of software testing and part testing. So in the concepts and in unit 1, just we are going to have an introductory knowledge about software testing introduction. So what is the purpose of testing, and what is dichotomies, what are the models for testing, and what are the consequences of bugs and taxonomy of bugs. And we are going to discuss about much on structural testing. So structural testing, we are going to discuss about flow graphs, path testing, basic concepts of path testing, and predicates, path predicates, and available paths, and path sensitizing, path instrumentation, and applications of path testings. So in this lecture video, just we are going to discuss about the basic concepts and principles behind the software testing. Let us move on this. So what is software testing? Software testing is a process used to identify the correctness, completeness, and quality of the developed computer software. So software testing is a process we are going to identify the quality of the computer software on the basis of its correctness and completeness. So it includes like set of activities conducted with the includes like a set of activities conducted with the intent of finding errors in software so that it could be corrected before the product is released to the end users. So software testing is a process just to ensure the correctness and completeness of quality which is in on the software which we develop. So for software testing, we are going to carry some set of activities that is going to be conducted on the aim of what? Finding the errors in that software so that it could be corrected before when the product is released to the end user. So that is the ultimate definition about the software testing. Software testing is a process used to identify the correctness, completeness, and quality of developed computer software which we going to give to the end user. So software testing is going to carry out a set of activities to finding the errors as a aim, and it is going to be corrected before the product is going to be released to the end users. So in simple words, you can see that software testing is an activity to check that the software is to defect, software system is to be a defect-free one. So in simple words, software testing is an activity to check the software system is a defect-free one. So defect-free is nothing but it is going to have a zero error before it is being given to the end user. So why software testing is important? Just we have to analyze it. So what is why software testing is important means before uh, the problems which we faced due to the software is enormous in our real-time world. More incidents being spoiled, and we have given up much leaves because of this errors in software. So we'll see some problems as an example. What happens when the software does not have does not going to work properly. So for example, in 1994, the China Airlines Airbus A300 crashed due to what? A software bug on April 26, 1994, killing 264 innocents' life. So people were dead because of this airplane crash. So airplane crash has been happened because of what? A software defect which has been occurred in the software system in the aircraft. So in 1985, Canada's Therac 25 radiation therapy machine malfunctioned due to software bug and delivered lethal radiation doses to the patients, leaving three people dead and critically injuring the three people. So this Thorac 25 radiation therapy incident is again a major incident which has happened due to because of software bug which has not been properly been traced out before it is being used in front of the patients. So some three people were dead and critically some injuring of three other persons were happened. In April 1999, again a software bug caused the failure of $1.52 million military satellite launch, the costliest accident in the history. The failed satellite launch in April 1999, it has been lost due to the software bug which has been happened on during the satellite launch. And in May 1996, software bug caused the bank account of 823 customers of major US bank to be credited with $920 million. Again, this has happened because of the software bug. So software bugs can be expensive or even dangerous. By this dangerous incidents, which gave us a lesson that software bugs can be an expensive or even dangerous one. So as we have a quote, Paul Eldridge puts it, to error is human, but to really foul things up, you need a computer. So this code definitely we can apply for software testing. If there is error which is caused by human, but really the fall things up, we need to have a computer to solve it. So here comes a software testing, which is being evaluated from the year of 1950s. So 1980s, sorry, 1980s. So manual testing is being done in 1980s to 1990s. So how this manual testing is being done in olden days? the methodology of waterfall technology is being used. So manual testing is done for the software which we create, that is being done with the waterfall model. So waterfall model is nothing but we all very clear about with the software engineering methodologies. One of the main model we follow to develop a software is waterfall model. So again, waterfall model plays a major role in manual testing in 1980s and 90s. A bulky automation tools being introduced in 1990 to 2000 late. There we have experimented with the many development approaches in software tools. So much automation tools being introduced, nothing but bulky automation tools being introduced in late 1990 to 2000 for the software testing. Then there is a robust automation tool with open source technology, mean agile methodology is being used from 2000 to 2010. So more scalable tools and frameworks being introduced after 2010 to 2018, like DevOps and DevOps continuous testing. And finally, now with autonomous testing, machine learning, and artificial intelligence, after 2090, we are beyond the collaboration with the smart testing methodology with of AI and machine learning techniques. So some top software testing trends in 2022. After 2022, we have listed it for some example: Agile and DevOps test automation, API and service test automation, artificial intelligence for testing, mobile test automation, test environment and data, integration of tools and activities. So these are all the top software testing trends in 2022. So we'll discuss one by one as soon as fastly. So in DevOps testing approach, there are different approaches being collaborated to form a continuous integration and continuous delivery of this testing approach. So in one side, you can see there will be a planning, code, building, test, and another side you can see monitoring, operating, deploying, and release of that software. So in DevOps methodology, you can see this DevOps testing approach is being used in many of the tools like Jira, Maven, GitHub, Confluence, TeamCity, Chef. These are all Appium, and these are all Splunk. These are all the software testing tools which adapts what DevOps testing approach. So this DevOps testing approach is based on continuous integration and continuous delivery. So automation testing tools, how we are going to use it right now. So automation testing tools are applications designed to verify the functional and non-functional requirements via automated test scripts. So automation in the sense we are going to just apply the test scripts which are going to be which are going to be applied to verify the functional and non-functional requirements of the corresponding software which we develop. So based upon that, the evaluation strategy is being framed, and the strategy will need to answer the questions like what features we are looking for, who's going to use the tool for testing, DevOps or QA team. Can it be integrated with the CI and CD pipelines or tool chains? Is it easy to maintain scripts and reuse test assets? What is your team's budget, and where can you get support for technical issues? So these are all the questions as strategy is being framed for this automation testing tools. So now we'll have some comparison of different products like Catalan Studio, Selenium, Appium, and Test Complete and Cypress. So here they have compared with what are all the applications can be tested under the different products and what platforms it supports, and what is the setup and configuration for this different products, and what is the supported language for this products, and what are the advanced test reporting testing things is there, and what is the pricing of all these products, and what is the ratings and the reviews given for these products being displayed here. Just we'll go through it fastly. So Catalan is a product which tests under the application of web, API, mobile, and desktops, and Selenium is an application under the test of web. Appium is a product which tests under the mobile, Android, iOS, and Test Complete is the application under the product of application under web, mobile, and desktops. So Cypress is again a web-based application. So we can see this product supports Windows, Mac OS, Linux, Solaris, and all this being differentiated here. So what type of setups, all these things. So we can go through of this. So what is API testing? So API testing, again, we are going to have some different test cases which are going to be developed, like coding of test scenarios, creating a sanity check set test suits, surveillance test suits, and test execution and reporting, nothing but execution of developed test suits and reporting, API specification review, reviewing the API specifications and use case documentations from the test perspective. And test specification development is nothing but it's a document which details the test condition and expected results of each test cases. And we are going to have a test frame development. And finally, we are going to use standard open source tools like JMeter, SoapUI. Develop it is going to have a static resources. So this is all the steps which we are going to undergo with API testing. So why do we use AI automation testing? So enhanced accuracy can be achieved. By accuracy can be achieved so that we are going to have in saving in time and money, greater test coverage, and enhanced defect tracing, improved recursion and testing, and we are going to conduct many visual testing, automated API test generation, and we are going to have a self-refer of Selenium test, prognostic analysis, and enhanced writing of test cases, and finally, emerging and evolving of bots. So this is about interface of the mobile test devices, how it is being automated interface with the test drivers and device interfaces for software testing. So here you can see our mobile devices, and in between the test automation framework and with the mobile test devices, device interface and test driver interface, and finally the test report is being resulted. So we have a test data and test environment management. So it is going to be done by the production and test environment. So production side, we are going to have our data, which is going to be interconnected with VPN to our test environment. Here in test environment, we are going to have our database server, virtual scan, and intranet, internal net web applications. All those this being cloned, and with this being in test data management, we are going to do data profiling, data cloning, and data masking. So these are the steps given here to just go through with this test data and test environment management. And finally, now we have just gone through with the evaluation of the software testing. Now we'll discuss about what is testing actually. So testing is nothing but verification of functionality for confirmation against given specifications by execution of the software application. Just we are going to verify the functional requirements to confirm against the specification when it is executed. So if we are developing some software application, we have to verify that functionality by confirming against what are all the specifications given by the customer, is this being achieved or not. So when it is being tested, the three things can be possible, nothing but a test may pass, a test may fail, or test may get what? A bug, defect, or fault. When test get passes, when the functionality is getting okay, the test will get passes. When the functionality gets failed, means nothing but application function is not okay at that time. And when we'll get the bug, defect or fault means there is some deviation from expected functionality means we will get what? Bug, defect or fault. Pass is nothing but functionality okay. Fail is nothing but functionality is not okay. Bug, defect or fault is nothing but just there is have some deviation from expected functionality. That's it. So it is not obvious that it is always the function will get bug, defect or fault means it is been failed. If we get a bug, defect or fault means it's just a deviation from expected functionality. It can be what? Rectified by use of some testing tool properly. So to catch the bugs, we are going to have a bugs that is due to imperfect communication among the programmer, specification, design, and low-level functionality. So statistics says that if you are writing some 100 statements, it's about 3 bugs or can be possible there. So they have given the productivity released reason. So inefficient effect in QA and high rejection ratio, higher rework may cause what? Higher net cost. So statistics says that QA cost is due to 20% of customer products and 80% for critical software. So quality will be depends upon in the productivity. So goals for testing, we can see the primary goals of testing as bug prevention. So why we want to go for testing? The primary goal is to avoid the bug, to prevent the bug. So bug can be prevented means we can save our rework. So bug reporting, debugging, correction and retesting, all this being possible in the primary goal as bug prevention. Then test design thinking, nothing but from the specification, we have to write the test specification first and then code. So it eliminates the bugs at every stage of software development life cycle. It's nothing but SDLC. If this fails, testing is detect the remaining bugs. So 5 phases in testing tester's point of view. It's nothing but phase 0 says no difference between debugging and testing, but today it's a barrier for good testing and a quality software. So we'll discuss that 5 phases. So phase 1 says testing is to show the software work. A failed test show software does not work even if many tests passed. So objective is not achievable. And phase 2 says software does not work. One failed to test to prove that, and test ought to be redesigned to test corrected software, but we do not know when to stop testing. And phase 3 says this test for risk reduction. So we have to apply the principles, statistical quality control, our perception of software quality changes, consequently perception of product risk reduces, release the product when the risk is under the predetermined limit. So in phase 4, a state of mind regarding what testing can do and what cannot to do, what makes software more testable. So applying this knowledge reduces the amount of testing, testable software reduces the effort, testable software has less bugs than code hard to test. So cumulative to goal of all these phases is nothing but cumulative and complementary one leads to other. Phase 2 test alone will not show the how software works. Use of statistical methods to test design to achieve the good testing is acceptable risk. So most testable software must be debugged, must work and must be hard to break. So some of the points to remember here, test design has to be created. After testing and correction, we have to redesign the test and test the redesigned test. And we have to go for bug prevention, mix of various approaches depending on factors, culture, development environment, application, project sites, history, all language, these are all the areas we want to prevent a bug. So we have to introduce the inspection methods, design style, statistic analysis, and languages which have a strong syntax, path verification, and other controls, and the design methodologies and developing environment has to be chosen properly. So these are all some of the introductory part or in the software testing to understand the basic concepts in testing. So just we have gone through with the purpose of testing today. So what is the need of testing and how the software testing is being evaluated. So finally, why we want to go for software testing? We need to get a defect-free software before it delivered to the customer or end user. So thank you. So we'll continue with the next lecture on software testing. Thank you all.